Chapter 7.5, we're looking at exponential functions, and specifically today, we're going to be graphing exponential functions. So let's take a look at what an exponential function is, and then we'll get into the hows of graphing an exponential function. So an exponential function is a function that looks like this. Okay, so notice that we have an x and a y. And so that x and y tells us that we're probably looking at putting this on a coordinate plane. The a and b, those are numbers, right? They stand for something, and we're going to put some numbers in there. There's some rules that go with those numbers. So let's look at the rules, and then we'll look at some examples of what an exponential function might look like, and we'll go from there. So first of all, we have to say that a, which again, a and b, those are going to be numbers. The a can't be 0. If the a was 0, then 0 times anything, this whole thing would be 0. Y equals 0 would not be an exponential function. So a cannot be 0. The other thing that we're going to go ahead and say is b. B is that number that's going to be raised to a power. That b has to be positive. So greater than 0 says that my base has to be greater than 0. Can't be a negative number. Okay. We could talk about why, and maybe we will, but for now, just to say that base can't be negative. The a could be negative, but the base cannot be negative. And then one more rule is that the base can't be a 1. Okay. Base can't be 1. 1 raised to the first power is 1. 1 raised to the second power is still 1. 1 raised to the third power is still 1. So that base can't be 1. Otherwise, this thing is not exponential anymore. Now it's just y equals some number. Okay, so those are the rules. Here are some examples of what exponential functions might look like. So in this first example here, y equals 2 times 3 raised to the x power. Notice that the 3 is the only part of this function that's being raised to a power. The 2 is a coefficient. It's sitting out front here, and it's saying, okay, once you figure out what 3 to the x is, take that and multiply it times 2, and then all of that together is what equals y. So 2 is a coefficient. 3 is what is being raised to a power. In the second example, you'll notice that we don't have an a, right? There's no number in front of the base. That 4 is the base, the b. 4 raised to the x power. And so sometimes we don't have an a. Sometimes we do, sometimes we don't. And this last one is an example of an exponential function that has a fraction, right? So we said that my base couldn't be 1, and we said that our base had to be greater than 0, had to be positive, but it can be a fraction, right? Fractions fall between greater than 0 and 1, right, which it can't be. Can't be 0, can't be 1, but it can be between 0 and 1, and it can be anything greater than 1. All right, so let's jump in here and let's graph some functions. Now here's what we're going to be interested in doing. We'll graph the function. We'll talk about what the y-intercept is. And probably in class a little bit more, we'll talk about domain and range. For now, just to say that domain, we're talking about the x values, and range, we're talking about the y values. And so we're going to be interested in where that graph goes left and right, and where that graph goes up and down. But for now, let's just focus. I want to focus in on the graphing part. So here we go. We'll graph the function y equals 2x. So not knowing what that function looks like, we probably want to, and this is just a good old tried and true method of graphing, is let's grab us a, I'm going to have to pick a different color here. Let's grab us an XY table. Now, XY table suggests that I'm going to be picking X values, plugging it in, and then finding the matching Y value for coordinates, right? X and Y tells me I'm looking for coordinates, right? So 0 might be the easiest one to start with. So let's pick x equals 0. Okay. So y equals 2 raised to the 0 power, which is 1. So y equals 1. And so that's a coordinate pair. X is 0, y is 1. We'll come back and graph that in just a second. Let's pick x equals 1. So y equals 2 to the first. 2 to the first is 2. So x equals 1, y equals 2. Now this feels kind of coincidental right now, but let's go ahead and pick x equals 2. Right here we're just going 0, 1, and 2. We're picking along the x-axis here, just trying to find out what this graph is doing as it moves across there. So as y equals 2 squared, right? 2 raised to the second power. So y would equal 4. Okay. Now let's go ahead and see what happens. Let's go out one more. Y equals 3. X equals 3. So y equals 2 raised to the third power, and 2 cubed is 8. And so I'm going to stop right there, and let's put these points on our coordinate plane here. So x is 0, y is 1, x is 1, y is 2. And if you stop right there, it looks like a straight line, but let's see what happens next. X is 2, y is 4. Well, that's not a straight line anymore. It got a little extra something there. X is 3, y is 8, which jumps clear off of what I have available to me here, but that's about where it would be. And you'll see that from 0 on, right, this is that, there's kind of a curve going on here. It's not a straight line anymore. It's a curve. And it's a pretty steep curve. And if we went on to x equals 4, if we picked x equals 4, y equals 2 to the 4th power would be 16, right? So 16 jumps even further up. So the further to the right this thing goes, the steeper it gets and the higher that it climbs. Now, we don't know what's happening to the left at all yet, so let's pick a few numbers that would go to the left. In other words, let's say that x equals -1. Remember what negative exponents do. They create reciprocals. They move things from numerator to denominator. So y equals 2 to the -1 would take that 2 that's in the numerator and flip it to the denominator, and now it's 2 to the first on the bottom. So that's just 1/2. So x equals -1, y equals 1/2, -1 and 1/2, and this is kind of estimating here, but we'll get as close as we can. If x equals -2, y equals 2 raised to the -2. Okay, so that's going to take 2 and move it to the bottom. It's going to be squared, so that's going to be 1/4. Right, so -2 and 1/4, so we're getting smaller. And here's what's going to happen. We'll go ahead and do 3. Sorry about that. -3, and so that would be 1 over 2 cubed, which is 1 over 8. Right, so we're getting smaller and smaller up here. And so the further left we go, the closer we're going to get to 0, but then there's nothing that's ever going to actually get us there. This is what an exponential function is going to look like. It's going to look like on one end it's going to get really close to a line, and on the other end it's going to get really steep, really steep, really steep, and it's going to get steeper and steeper and steeper. Okay, so we're going to be looking at patterns, and this is what happens with a whole number, a larger than 1 base, right? 2 is larger than 1, and so this is the general idea of what an exponential function will look like for numbers larger than 1. Let's do one now that's a fraction. Okay, let's do one that's a fraction. So same concept here. I'm going to need to do an XY table. Okay, so I'm going to pick X values. Some of you are not really sure yet what I'm doing. I'm choosing X values, I'm plugging them in, and I'm evaluating. Okay, so I'm going to go ahead and just 1, 2, 3, 4, All right, we'll pick those first four values, and then we're probably going to be interested in some negative numbers, and so we'll work back the other way. And by that time, maybe you'll see a pattern. So here we go. Y equals 1/2. 1/2 to the 0 power is 1. So at x equals 0, y equals 1. All right. Y equals 1/2 to the first power, which is just 1/2. So at x equals 1, we're at 1/2. Now that's not quite what the other one did, right? You're noticing that. Y equals 1/2 squared. That's 1/4. So at x equals 2, we're at 1/4. So we got a little closer. I don't know why I skipped 3. Let me go back and we'll grab 3. That was crazy. I don't know what's going on there. So let's pick 3. Y equals 1/2 cubed, which is 1/8. Okay, so here we are, and we're getting lower and lower. And so lower and lower and lower. Now, we should probably at this point be able to guess what's going to happen the other way, but let's just work a few of them out just to make sure we see what's going to happen. So let's start here with, we'll start with -1, -2, and maybe we'll go ahead and do -3. So y equals 1/2 to the -1 power, which is going to take that whole fraction and just flip it, and it's still raised to the first power. So at -1, y equals 2. 2. So -1 and 2, which that's kind of what we expected to happen on the other side. Let's try -2. All right, so the first thing that negative does is it flips my fraction. And then we can do 2 squared, which is 4. So at -2, we're at 4. And I think you see what's happening here. We won't go any further. All right. The climb that we saw on the other one, we now see on the negative side, right? So the difference between a positive, a number greater than 1 raised to an exponent, as opposed to a fraction raised to an exponent, is the way that the increase goes. That graph is increasing as it goes off to the right, or it's increasing as it goes off to the left. That's going to be the difference between a base that is a whole number and a base that is a fraction.